In this short video, we're going to use StatCrunch to do a chi-square test of independence on a contingency table. So we have a problem: are health and happiness related? The following data represent the level of happiness and level of health for a random sample of individuals from the General Social Survey. Does the evidence suggest that health and happiness are related? Use alpha equal to 0.05. So we see in the table we have the individuals categorized by their level of happiness and also their level of health. So the first question is, what are the hypotheses that we're going to test? So when we do a chi-square test of independence, our null is always that the two variables are independent. Our two variables here, we're going to call them health and happiness. Just write it that way. So health and happiness are independent, and then our alternative is always going to be that the two variables are either dependent or not independent. They mean the same thing. So health and happiness are not independent, or some people say dependent. It means the same thing. Okay, we want to calculate the test statistics. So I have the data here in StatCrunch. And I noticed in my first column, I have the levels of happiness. And then in the next columns, I have the counts for the different categories of health, excellent, good, fair, and poor. Notice there's no totals here. You don't want to have any totals on the contingency table data summarized when you enter it into the spreadsheet, into the StatCrunch spreadsheet. So we're going to go to Stat, Tables, Contingency, with Summary, because the data is summarized. So first thing we want to pick are the columns with the counts. And those columns are the levels of health: excellent, good, poor, and fair. And then the row labels are the happiness levels. And remember, they're very happy, pretty happy, not too happy. And then down here under display, I'm going to display the column percent, because I want to show you, once we see the chi-square test and our interpretation, what is really going on with the data set. So let's go ahead and calculate, and let's scroll on down to the chi-square. So here's my chi-square test statistic. I'm going to go ahead and put it over here. And so my chi-square test statistic is equal to 182.2, and the p-value is very, very small. It's less than 0.001. And remember, the degrees of freedom are the number of rows minus 1. So we have 3 rows. 3 minus 1 is 2, times the number of columns minus 1. 4 minus 1 is 3. So 3 times 2 gives us the 6 degrees of freedom. So I put the p-value up there. What is the p-value? We've got it up there. And what's our conclusion? So our level that we were testing at was 0.05, so we're definitely going to reject. We're going to reject the null. And so what does that mean? It means there's some kind of association between the two variables, and that's why I went ahead and I did those column percents. And if you take a look here, by doing the column percents, what I've done is within each level of health, excellent, good, fair, poor, I've looked at the distribution of the levels of happiness. So for people who said they were in excellent health, nearly 50% of them said they were very happy, and only about 6% of them said not too happy. If I go to the other end of the health scale, for those people who said they were in poor health, only about 18% of them said they were happy, but 33% of them said they were not very happy. So there's an interesting relationship there. Now, again, with a chi-square test of independence, it's one-sided. It's only a right-tailed test. We can only say, if we reject the null, that the two variables are somehow related, but we can't really conclude that one is causing the other or that the relationship is a particular relationship, only that there is a relationship.